Okay, so in this video we are going to train the CRESI algorithm to extract road network. So this algorithm was developed from Spacenet 5 challenge, and we are going to again rerun this model. So to do that, what we would first do is follow the instructions which is given here. So we are going to use these instructions. So essentially we are going to follow these steps. Mainly what we are going to do is we are going to pull this Docker image, which is the CRESI algorithm which runs on GPU, and then clone the repository and then run the container and train the model. So to train the model we would require GPU, and my system does not have GPU. So what we would do now is take some instances on AWS and train our model there. So to begin with, what we would do is we would launch spot instances. So I've opened EC2 and then gone to spot instance. So we'd request one spot instance now, and then we would be selecting AWS deep learning base AMI, which is Amazon Linux 2. So this contains all that we need. So it contains Git, it contains Docker, it contains PyTorch. We don't need PyTorch actually because we're going to install in Docker, but it has NVIDIA drivers and all those things. That is why we're going to use this. I'm just selecting my key pair, and then we go to additional launch parameters and then choose our EBS volume. So for this case we would require 150 GB of SSD. We are going to choose SSD GP2 because that is faster than GP3, and then we would require, so when you install deep learning base AMI, 70 GB is already taken up by all those resources, all those softwares, and we are remain with the 75 GB, and that will be sufficient. To download images it will require around 50 GB. 50 GB is more than enough for our training set. Okay, so and then we go ahead and select a security group. If you don't have security group, you can create a new group and then make sure that port 22 is open. And apart from that, what else is required? Okay, so I think that is it, and then we just have to select our instance type. So we are going to manually select instance type that is required. What we would do is we would add one instance. We need to make sure that it is a GPU instance, so we go for G4DN, and CRESI algorithm, when I tested it, turns out it requires only 12 GB of RAM, considering it is 32-bit precision. So we are okay with having 16 GB memory, and we select this and delete the other instance. So considering this instance, we would go ahead and launch. So once we launch our instance, you can see I already tried many times because I was testing out as to how it would run, how much time it would take. So let us see, it should be active now. So it is active. In case you get some error, it might be because of, go check, just select that and go check your, let me just select this, go check the history. Here you would find all the description as to what has happened. If you just refresh it, here I would see all your history. It says it's submitted. If in case you get error, it might be because there is not enough limit for you to activate or get the instance. So you have to submit a request to increase your limit. So you can go to, I think, services or limits, I think. Service quota. You can go to service quota and choose and select that you want your G4 instances to increase capacity. By default it will be 0 capacity and you have to increase it to 1 in case you get error. Okay, so our instance is now active, so we can go ahead and connect. You can just copy this, make sure you have your key pair ready. Let us bring this. So let us log in to our machine. We have to change this to EC2 user, and I think that is it. Let me just okay, and then type in a password and click yes. Okay, so we are in, and first step we do is we do sudo yum update. Where did I type some yum update? Sudo yum update. So while updates are taking place, we can see what next steps we have to follow. So what we would first do is we would clone our repository and then pull the image. So you would see that we have these folders. To just explain what these folders contain, we would first go by result AWS weights. This contains the already trained weights. So the competition, from the competition you have pre-trained weights, you can either use that, or if you want to do any modification, you can train as we are doing it now. So notebook contains how to infer or how to predict. These are the things here. In Docker contains the Docker image for both CPU and GPU. CRESI contains the code. So everything we do now will be related to this folder. Okay, so let us go to this section, and first we would clone the repository. Okay, so I think it is done. Now we can go ahead and clone the repository. Okay, that is done. So next step, we pull the image. This might take some time because it is of size 12 GB when you uncompress it. Okay, so it took some time to download, to pull the image. So once we have this image on our machine, we can I think it is best to reboot it. So we would first reboot the system of the machine, because I think it was hanging, and then just going ahead and seeing what the next steps are. So now we would create the Docker container because we have our image. To explain this in brief, what we are doing is we are running this interactive mode. RM is we are removing the container once it stops, or remove the stop container. GPUs is, this is important, it just says Docker that you have to use the GPU. One is how many GPUs you want to use. If you have multiple GPUs, specify all or 2 or whatever, how many GPUs you have. And volume is your local directory, what you want to point out to the directory inside the container. You're opening a port, this is not required here because we are not going to use this, but anyway. Then IPC host is just for memory management. Then if you go ahead and select the name, this we are giving the container a name. This is the image name from where we want to create a container. Okay, so we are going to copy this and log in again to our image. Okay, so we are in now. Now we can go ahead and run the container, but before that we need to change our directory, local directory. So for that, let us ls. You can see that we have a CRESI modified folder. This is our git clone. We go inside and do pwd, get this path, and then change the path of our local dir. Not this, but this. Okay, So now we have specified entire thing for Docker run. We can go inside. Okay, so you see that when we run this command, we are in opt CRESI directory. This is the default which it specifies, and also we have a base conda environment which contains all our environment, all our packages. Okay, so now we are ready to follow next steps. So the next step is we have to set up few paths and then download the training dataset. Okay, let us do that. Paste anyway, enter. Okay, this is done. Next we have to download our image. We follow the entirely the same steps as it is given. I think yes. So here what we are doing is we are syncing an S3 bucket. So this is the bucket which contains our training dataset. There are many training datasets in the sense that there are many regions. If you know about road extraction, about CRESI, about Spacenet, there are many areas of interest. We are only selecting a subset which is Mumbai. So from Mumbai we are only selecting one entry, or we should see here, this is pan sharpened multispectral imagery. This is what we are downloading, this folder, and then storing in our path. This is the path where we are storing it. Again, this might take some time because it is 25 GB of data, and once we click enter, it should start downloading. Okay, so our training dataset is saved to this path. So just to confirm how much space we have left, I would do dh minus h, and we see that we still have 45 GB left, so nothing to worry about as of now. And then we go ahead and download the GeoJSON data. So something to note, that this contains the TIFF files, the pan sharpened multispectral bands. So there are 8 bands in each image. Each image is of size 1300 by 1300. So this contains the road network for this image. So we need to now generate masks on top of this image. So we overlay these roads on top of the existing TIFF images and generate masks. For that, there are two steps. One is first to convert our images to 8-bit for training, and the other is we are creating training masks. Now we do this because Spacenet 5 and Spacenet 3 had different bit size, and that is why it was recommended that you convert it to 8-bit. But if you are only using Spacenet 5, then this is not a necessary step. But anyhow, just following what was described in the competition, we are doing this now. We copy this and then go ahead and paste it. Oh, but before that we need to download the road networks. So cancel this and then paste it. Again, same thing, we are downloading the images, downloading the road network from S3 bucket, and then this should be quick. It is not a large size. Okay, this is also done. Now we go ahead and we are not downsampling the data here. I forgot to remove this, but we are only converting to 8-bit. So let us copy this and then let us see what we've got. So here you can see that I am specifying a create 8-bit script, and we are passing the input image, which is panchromatic, pan sharpened multispectral, and converting to RGB. Here we are specifying the rescale type, which is percentage, and percentiles are 2 to 98. Band order is for PSMS because it contains 8 bands. We are saying which is red, which is green, which is blue. So this is what we are doing. Again we run. It might take some time to execute. Okay, so we have rescaled our training images, and the next step now is to create multi-channel training masks. Let us clear this. paste this. Okay, so here what we're doing is we are reading in, or we're using the speed mask script. Here you are specifying the GeoJSON where our directory is, a GeoJSON. This contains the image directory where our images are, the output conversion pane where do you want to save it. This also is again saving path, and this is again saving path. So all these saving paths and this buffer distance 2 meter, which says that if you're when you're drawing or putting a line, what is the buffer size that you want around the road, around the center line. Okay, so again this, when you run it, this might take some time to run because it contains 1016 roads. Also notice that there might be some empty masks, and meaning that there are no masks or there are no roads in the this on that chip. Okay, so after a long time this also finished processing. So now we have done with most of our pre-processing. So we have created channels, training masks as well. Now we come to the main part, which is training. So just before training we need to create the folds. Folds is like how many do you want to train on, how many do you want to validate on. So here we are just splitting, we are just doing one split, that is out of the all training data set we are splitting 75-25 and not doing cross validation here. That might take a lot of time, so that is why we are only doing one fold or 0 fold. Okay, so this is also done now. Our folds save path is saved here, it is at this place. So the last step now is you can start the training. To start the training we copy this path and then paste it. So we are running this script here. So this script generated the folds, and this script will now start the training, and when we press enter, there you go. So it printed out the model, and any moment it should start training. So here it is saying that fold 0 checkpoint is not found. Nothing to worry about that, because we are running for the first time. It is just showing us this. Okay, so there are some few warnings which need not be worried about. It is just showing that because I forked this repository from the original CRESI upstream, it was quite old and I did not change the PyTorch functionality, and those are depreciated but still functional, so nothing to worry about, it will run just as fine. So the epoch number was specified in the JSON path, the JSON file, which is this SN5 baseline or JSON. If you look into this file, which is stored under CRESI, and let us load it, CRESI configs and SN5. Here you would see epoch. Here, there you go. So you have 10 epochs now. You can train as much as you want. By default it was 70, I changed it to 10 just to make it not quicker. And while it is training, let us wait for one training and see the loss at the end of the training. So after it completes one epoch, it will start validating and then continue for 10 epochs till it finishes. Once it finishes off, then the model saves its weight under the directory, which might be again specified in this JSON file, save weight stir. So it would save under this directory, SN5 baseline. So here we see that our training was done and evaluation also completed. We also see that our evaluation took a lot lesser time and our second epoch started now. So that is the entire process of training the model. Once you train the model, you can then go ahead and predict on any image. Just to note that this images are trained on 30 centimeter resolution. You can change that as well, resample or downsample it and then train it. The process would still remain, the entire process would still remain the same. Okay, so once you complete this, I will stop it now because I've already done this. Close this, shut it down, shut this down as well, and then again don't forget to go to your Spot instance and then cancel the request. Spot instance is the right fit for this kind of job work because you are only training it once and the price also is quite cheap. So I would be saving 50% on this request. Also to note that because we have taken 150 GB of SSD for this process, it would not cost much again because it is charged per second. That is the way you train the model, CRESI model, and that is all from this video.